So yes, you're right. Kind of if any number repeats, then you're right. If x repeats, that means that an x can have two possible answers, right? And here, if y repeats, that means y can have two possible inputs, right? So that's why this one's not 1-to-1, because the y has two x's. The top one, the number 2 that x has two y's. So this one, here's an example that would be, is purple. Purple is 1-to-1. Is 1-to-1. 2-1. I don't know. 1, 2. That's okay. 3, 4. 4, 5. Right. Every x has only one y. There's no repeats of the x's. There's no repeats of the y's either. Each y only has one x. Okay. So they can go back to each other, right? They can go back and forth, but it's fine because 2 only has one output, one y, and 1 only has one output, and the output of 2 only has one x. Right? Okay, so where were we? Okay, so that's this first part. The second part is see if they're 1-to-1 or not. So that basically means just draw lines. Right, draw a vertical line and draw a horizontal line, and see if they pass the vertical line test and horizontal line test. Right, just draw lines, draw vertical line test and horizontal line test, and see if they pass. So that's all the rest of this. I think we should, yeah, there's 4 of those. Okay. So that's that homework. It's due next Wednesday. It should not take you long at all. Well, so again, that's due on Wednesday. Let's take a look at number 3. So now we're going to do intro to linear functions. Intro to linear functions. There we go. There we go. And is it you? Good. So let's go ahead and start with this one. At a university, student, why am I reading? Fox, read for me.
At a university, student tuition costs consists of a matriculation fee of $150 and a fee of $200 per unit. The matriculation fee is paid regardless of whether a student enrolls in classes. Complete a table of values and graph the data. Find a linear function that represents this data.
Okay, good. So, what's going on? So what are the two things we have here? What are the two things that vary in this problem? That have different possibilities, different numbers?
Matriculation fee.
Okay, well, no, the tuition fee is always 150. That doesn't change. That never changes. Well, the two things that change.
The amount you pay for,
The amount you pay, okay?
for the fee and.
Oh, it stops there. So the amount you pay, you guys over here, someone's got to talk to your neighbors, so come up with an idea. What's the other thing that changes? The amount you pay, and what else changes?
The student, that's all.
So, I guess, what changes from student to student? What's it?
How many?
The number of units, right? So, the number of units they take and the amount they pay. Which one do you have more control over?
How many units?
Units you take. So that we usually make that our X, the one you can kind of control. So our X is the number of units. And then our Y is the amount paid. Okay, so let's take a look. What are some of those numbers? If I take no units at all, I'm just going to put in some options. How much should I pay if I don't take any units at all? I take nothing. No,
Pay 150.
you still have to pay this 150 no matter what. It's like a registration fee.
Oh, even if you don't take any.
Yeah, whether a student enrolls in classes or not. I would fill in, take one class, 1 unit or 2 units or 3 units, fill in the rest of them. Fill in the rest of this. Find the rest of these. Yes, find the rest of them. So 150 you don't take any classes at all. How much is it if you take? So 200 per unit. So if you take, so you always have to pay the registration fee, the matriculation fee, and then on top of that you have to pay money per unit for each unit you take. You always pay this amount, but then you also pay this amount, $200 for every unit you take. So each unit costs $200.
So it's,
Okay, so I pay $100 no matter what, plus $200 per unit. So here, $150 no matter what, plus 1 unit, $200. Right? So how much is that? 350. If I take 2 units, that's 200 and 200 plus 150, 550, and 3 units, 750. Thank you. Great. Find a linear function that represents the data. Okay, so what's my increase? So for every x, what's my y equals? For every x, for every unit, how much do I pay? How much is an increase for every unit? 200. So this is my, kind of like my amount per unit, right? Amount per unit, per x, per unit. And then we have what we call an initial amount. What's my initial amount I pay no matter what? 150. That's what we call our initial amount. kind of what you start with, right? No matter what, if you're a student, you're going to start paying 150. That's your starting point. And what that goes for is like, student fees and health. I think we always had because university should give you health care, student health care. It's never that good. I remember our joke was, if you go into the UC Berkeley Student Hospital, the first question they ask you is, are you pregnant? No matter what. You go in for a cut, are you pregnant? That's like, they always ask you that. I know, it's crazy. I don't know if they ask guys, but that's what they asked us. Okay, so then we're going to graph this. And get some lines in here. Graph some lines along there. Along there. And what do we have? Oh, you know what? Stop. If you didn't draw them yet. The thing about these is that these are word problems. So very rarely do you can't take -1 units. So we're going to move this down so it's more like that. Do you guys see what I'm saying? And you're never going to pay negative money, right? Does that make sense to folks? So you're going to, so you can leave it where it was if you had it, but as you're going to find with these word problems, they only make sense when x is positive and y is positive. Right? Because you can't make -4, you can't sell -4 cameras. You can't make -4 pies. You can't pay -$20. Everything's going to be on the positive side. All right, so what do we have? We had 0, and my x's were 0. There's a lot of space here, so and tiny. So I'm just going to make this 1. I'm going to make that 2. I'm going to make that 3 because I can't make that small. Okay, and then we start off with $0. And then do I make each one of these? I'm going to make every 200. So I'm just going to go with this one. So every line is going to be $50. So there's 200, 300, 400. Because I know I need to go up to 400 and 550.
750.
750. Oh, I might have miscalculated that. Oh well. No worries. We'll go up over 1. Okay. So where are my spots? No matter what, I pay $150. So when I'm taking 0 units, 0 is 150. Everybody find the other 3 points that you guys did on your little table right above. So I think everybody's got it. Let's take a look. 1 goes with 350, 2 goes with 550, 3 goes with 750. I just have to go up a little bit. And then just draw a line connecting those. Good? Everybody that?
So if you flip this like you didn't know and just put the x's and the y's and the y's and the x's on the top here when you first started it, would it be wrong?
Okay, so that's a good question. If you flipped it, you made your x's your y's and your y's your x's. It depends on what you had up top on your table. It should match the table. So the x's on your table should match with the x's here.
Right, but it wouldn't matter though on the first table if we flipped it and then we did it.
So the question is if you flipped the first table.
Yeah.
So in this class, probably not. However, time or what you can control should be on the x. So in general, it's what we call our independent variable. It's the one that we can control. And we can control how many units we take. We can't control how much money that we have to pay. So the thing you can control is what we call your independent variable. That's what should be along the x. Good questions. Oh, the ratio you obtain when finding the slope of a line is often referred to as change in y over change in x. Who's ever heard rise over run? Yep, or also it's also known as rise over run. So you figure out how far your x has changed and how far your y has changed. So to look at this, we can take these points and we can say, okay, from this spot to that spot, how far do I rise? I rise, or let's pick two that are both on the grid. From this spot to this spot, how far do I rise? I rise 50, 100, 150, 200. I rise 200, and I run 1. So this would be a rise of 200, and a run of my rise. Oh, you can't see that very well, can you? My rise is 200, and my run, as I run along there is 1. So that means my slope, we call her M. M, as we know, is our slope, is 200. That's why we have y equals, who's ever heard of y equals mx plus b? Yeah? Most of you guys heard of that one? Right, m is our slope. And b is our initial amount, our starting amount. Initial means what do you have in the beginning? Initial amount. Initially, you have initially. You initiate it. So have you heard of initiation at the beginning? Right? So the beginning amount. Alright, so there's some common, you guys have heard of all these ones, I'm sure, like miles per hour. Who has not heard, you guys have all heard of miles per hour, right? Per means divide by, over, right? So miles over hours, so how many miles you did over per the hours you do. So you change in your miles over change in time. So if I want to know the miles per hour that I drove to get from here to LA, I'd take the distance I drove, I divide by the time it took me to get there, to drive that. And then I get my miles per hour, my average miles per hour. Miles per gallon, right? I do this all the time. I figure out I look at my little A thing counter to see how many miles I drove since my last fill up. And then I divide by the total number of gallons I bought to see if my car really is getting 32 miles per gallon instead of 29 or something like that. So that's 2 miles per gallon. So those are some basic ratios you guys are familiar with. Right? Or dollars per hour. Ooh, you guys are totally used to that one, right? How many dollars you earn per hour. So then you know that if I earn $12 per hour, if I work 16 hours, it should be, whatever this should be, 16 times 12. Okay. Okay, go ahead and read for us. In?
Oh, this is the wrong packet. In each of these rates of change, the quantity in the numerator of the ratio depends on the quantity in the denominator of the ratio. For instance, how far you drive depends on the number of hours you drive. How much money you earn depends on how many hours you work. For this reason, the variable quantity in the numerator of the rate of change is called a dependent variable, while the variable quantity in the denominator of a rate of change is called an independent variable. In the linear function, f of x equals ax plus b, the value of
F of x. It's supposed to say f of x.
the value of f of x or y depends on the value of x. X is the independent variable, while y is the dependent variable, and the value of a is the rate of change.
Right, so typically, right, like we said before, how much you pay depends upon how many units you take. So typically this one, the value of the y depends upon the x, what you input into it. And so let's just before we go too far, I just want to like, make sure you guys understand this idea of the rate of change. So for example, if you make $12 an hour, then the amount you make, so y equals the money earned, right? X equals hours worked. And your rate, your M, is $12 an hour. Everybody all right with that part? So then we would have y, the amount you work, is equal to your rate per hour, $12, times however many hours you work. Are you guys, does this make sense for folks? Yes, no? The number of hours you work times how much you make per hour should give you how much money you got at the end. That's what I'm kind of, take an example you guys feel pretty comfortable with. Good? All right. So now we're going to take a look at these ones. So do these represent linear change or not? So the x's should all, they're all increasing the same amount each time. So it's increasing by adding 2 each time. Everybody with me? The x's are all going up by 2 each time. The y's should also go up by a constant amount each time.
Or down.
What was that?
Can it also go down?
Or down, yes. Okay, yeah, so think of it as increasing by a negative number, yeah. Decreasing, they should always increase or decrease by adding the same amount, whether it's a positive or negative number each time. Perfect. So here, excellent point. So from here, am I going, what's going on here? What am I subtracting 3? Next one? Subtracting 3. How do I get from 1 to negative 2?
3
Minus 3. David, how do you get from negative 2 to negative 5?
Subtract 3.
Yep. So this one is linear. This is linear change. It goes down by adding or subtracting a constant amount. How about the next one? What's the difference from here to here? I subtract what?
4.
Here to here? Subtract 2. Here to here? Here to here? So I do not subtract or add a constant amount. Here, I would be dividing by a constant amount, right? I divide by 2, divide by 2, divide by 2. When you multiply or divide by a constant amount, we're going to talk about that later. That's exponential, and that's not. We'll discuss that in chapter 7. Good? But here, this is not linear, right? Because the amount you're adding or subtracting each time is not the same.
Okay, so don't worry about dividing on this one.
Right? Yeah. Adding, subtracting is linear.
Okay.
Dividing that's exponential. We'll get to that later. So this is not linear. Good? Okay. Move on down. So now we're going to look at modeling. Ryan, go ahead and read for me.
In 1998, there were 84 million internet users in the United States, and this number has increased at a rate of 21 million users per year since then.
Keep going.
Make a table of values that models the information described. Let X represent the number of years since 1998.
X equals 0.
Yeah, X equals 0 corresponds to 1998. Is this data linear? Make a scatter plot of the data. Write a linear function which models these data. Find and interpret F of 14.
Okay, good. So, in 1998, so first I'm going to do the years. 1998, there were how many? 84 million. So, actually before we do that, what are the 2 things that are changing? So everyone take 30 seconds and think to yourself, what are the 2 things that are changing in this problem? What are the 2 things that are changing in this problem?
Years,
Can you give me one of the things that's changing in this problem? What's one of the things that's changing in this problem? The year is changing.
The number of users?
Yes, and the number of users. So those are my two variables. So we really can't control either one. So, but what we usually do is we usually have time be our x, or whatever we can control. So our years is going to be our x, right? And then the number of users is going to be my y. So my y is the number of users. So that was 84 million. I'll say in millions. There we have to write 84. And then my year, so my year is 1998. But here I'm going to call x. X is the number of years, after (1998). So 1998 is how many years after itself?
0.
0. And then we're going to go 1999, 2000. And maybe we'll do, so in 1998, there were 84 million users. This is increased by a rate of 21 million per year. So if 1998 was 84 million, 1 year later, there should be how many more? 21 million more. Is anyone seeing where we're getting that from? So this should be 84 plus 21. Yep, 105. Next one should be 105 plus 21. 126. Okay. Let's do a little, and then 1999 is 1 year after 98, 2000 is 2 years after 1998. So let's make a little scatter plot of this. We'll do 0, 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, 8, 9, 10. And they want to look at 14, so it means we should probably go up to 15 here. All right, so we're going to start with, this should always start at 0. Let me try to work with you guys in this one. So 15, 21, 300. So when I get to 400. Well, I was going to make this a little larger. That's okay. So I'm going to make every we'll make every mark equal to 25. So we'll make this. So this is 50, right? 100, 150, 200. 250, 300, and I'll make this will be 350. And then we should label it. Aha. So what's this side, what's the bottom stand for? This is years after, what year? 1998. Deja, what's the right side? The y-axis stand for?
Users?
Yep. Internet users. technically it's internet users in the millions, but we'll let that, we won't focus on that one for this, just get the points down. All right, so we need to graph this. So where am I at 0? In the year 0, when x is 0, what's my y? 84. So this is 50, that's 75. It's kind of maybe like right there. Graph the next two the best you can. Now let's figure out 10. After 10 years, let's see, so 10 years would be 2008. After 10 years, this should be 84 plus 10 times 21. Maybe we should do that first. So first, let's write a function that models the data. Okay, so I'm just gonna stick with y equals instead of f of x for now. You guys all right with that part?
Yeah.
Y equals. What's my rate of change? What's my m? Everybody write down what you think the m is. So it's mx plus b. So something times x plus something. So m is my amount rate of change. B is my initial amount. Fill in those spots. Fill in those spots. All right, take a break and fill those spots, and then start the video back again when you have filled those in.